Hello, Year 8. Welcome to Mr. Chan's classroom. How are you guys? It's good to see you guys here again. In today's topic, we will talk about factors affecting the chemical reaction. If you haven't already know, our chemical reaction that we do in Prague actually can be influenced by four different factors. You can actually make it really fast or really slow by using these four factors. So let's look at chemical reaction. So chemical reaction is technically when you put reactant and reactant together, two or more to form product or products. It can be more than one products, as you know. Most of the time, the product can be gas or solid. Sometimes both of them are together. Okay, that means you get precipitate, but at the same time you get gas as well. And the keywords that I want you to know are the following. So you have catalyst, a new word for you, pathway, activation energy, surface area, and temperature. You probably have heard of a few of them. Okay, so there are actually four factors affecting the chemical reaction that we're doing. There are concentration is your number one, followed by temperature, and then surface area and catalyst. You probably have heard of the first three, but probably not the last one, which I will tell you very soon. Let's look at number one. Did you know that concentration of the reactants right here, things that you put in, it actually affect how fast or how much the products are produced? It is quite obvious that the more reactant you put in, the more product are produced. Okay, what that means is if you put 150, I'm gonna draw this. If you have test tube, if you add these two test tube, so first test tube you have 150, the second one you have 150. Let's say there are 150 particles. I just make this up. Normally there are more than that, like billions and billions, if not. So if you mix these two together, you expect, because they join together and form stuff, you will expect to get 150 product back. Okay, this is just, remember, this is just a rough imagination compared to if you only put in 50 reactant and 50 reactant, you will definitely going to get only 50 product. Okay, so that's how concentration of the reactant actually affect the chemical reaction. Plain and simple, the more you put in, the more reactant you have, the more product you're gonna get. As simple as that. Okay, that's easy. Second one is temperature. Have you realized sometimes we actually heat things up to start the chemical reaction or to speed it up? As if you haven't realized, an increase in temperature actually means that the reactant can move faster and have more energy to break down bonds. When you break down bonds, you join with another reactants to form a product. So if you compare, I believe we have done this Prague before with the remember the hydrogen gas, one with room temperature and the other one I set it with 50-degree warm water. Yeah, that one. What we found was the warmer it is, the higher the temperature of the solution, the quicker the hydrogen was formed. So there you go. So the temperature of your reactants, if you heat them up, it will move faster. The reason why it moves faster, as you know, because of the heat energy. The more heat energy it absorbs, the more it vibrate. The more it vibrate, the more it power, the more violent it is, which allows it to break down bonds. Okay. On the other hand, I want you to think of this yellow color one. What happen if we decrease the energy? Yeah, what happen if I use ice cold water instead? Will there still be any oxygen form? If there is any oxygen form, would it still be as quick or slow? That's something to think about. The third one is the surface area. Alright, this one might not be as obvious, but let me explain what that is. So surface area here, I want you to have a look. I'm gonna draw these two things. So first, I got a piece of solid that is about that big. Alright, I got a solid about that big, and I have another of the same solid, but in this time I crunch it down. I literally use mortar, pestle and mortar to grind it to become powder. Which one do you have? Which one do you think has a bigger surface area? Okay, is actually the powder. Okay, what happened is this one has more surface area, this one has less surface area. Surface area here refer to what is the area that has been exposed outside. Okay, exposed outside. So if you look at this stone, only that amount, that much, the one on the outside is exposed to the outside, while in powder you literally, each of the tiny powder are actually all exposed to the outside. That's why it has a larger surface area. Okay, so what that means is the increase in the surface area mean that the more surface area for contact between the reactant. So as you know, temperature here allows the reactant to move faster. Okay, so if you combine that with high surface area like powder, it will gonna react even faster because there are more area of contact for between reactants. So the reactant's gonna go crazy and start forming products from the get-go. Okay, that's why we grind stuff into powder. So for example, like if you have Panadol, so if you're sick, if you want the Panadol to act quicker, you would want it to be in powder form. Okay, so if you, or another one, if you have heartburn, you know when you eat too much and you feel like you have heartburn in your stomach, like you're really nausea, you're about to throw up and stuff, and then you eat the heartburn tablets or powder, like if you put it in water and then you drink them, yeah, that is a chemical reaction to actually neutralize the acid in your stomach. So that is why we use powder instead of tablets, because powder actually has more surface area, and from there you're gonna feel better a lot quicker than tablets. Tablets still do the job, but then again, it has less surface area, which means less reaction. It's gonna slower reaction gonna take place. Okay, so last one, catalyst. This is a new word. So catalyst is a type of special helper chemicals that assist reactants to react. Okay, so it is kind of like, for example, when we have when we add things between a reactant, I'm gonna write a reaction now. So what happened here, you have your reactant plus reactant, right, to produce product. However, if I put catalyst here, this is where the normally where you write your catalyst just above the arrows. When you add the specific type of catalyst to that reaction, it's gonna speed up the reaction super fast. Okay, it's even faster than the concentration, faster than the temperature and surface area. It's just super quick. You're gonna get it done in so fast. I'm gonna give you an example. The example is your enzyme in your body. I'm gonna go back to the enzyme in a sec. I just need to tell you that, however, it does not combine with the reactants. It's just there to help. Okay, it is just some extra stuff that you add into it to help the reaction to go really fast. It does not combine to form. It's not gonna form product. It's still gonna be there at the end of the reaction. Okay, it is recyclable. Okay, you can recyclable. You can actually recycle that at the end. That means you can use it again. And what it does is actually offer a new pathway with lower activation energy. As you know, you probably don't know this. All chemical reaction need reactivation energy. Okay, that means it has to hit the activation energy to get the reaction going. So if it doesn't hit the activation energy, you're not gonna get anything. Not gonna get any reaction, even if two of them are compatible. Okay, so what catalyst does is actually offer a new pathway that have with lower activation energy. So that means it's even easier. So instead of, let's say, it require 50 degree before it can react, now it brings it down to 30 degree. So imagine that, it's gonna speed up so much. So one of the example is your enzyme. So in your body, did you know that you have enzyme to break down food that you eat? Okay, without this enzyme in your body, your food gonna be digested 10,000 if not times slower. So it has a special place in your in our chemical reaction. All right. So catalyst, remember, it is a special helper that assists in reaction. It does not combine with the chemical reaction. It is recyclable, and what it does is just offer a new pathway with lower activation energy. And we went through the power of concentration, we went through the power of temperature, and how surface area can actually affect chemical reaction as well. So thank you for listening. If write down this page in your book and show it to me for small rewards in class. Guys, thank you for listening. See you later. Peace.